Hello everyone. So I hope you have enjoyed the last 3 lectures of the linked list. In the first lecture we have discussed the brief introduction and the definition of linked list, why linked list is important. Then in the second lecture we have discussed the linked list as ADT, the comparison between array and the linked list, and the traversal pseudocode, the pictorial representations, and the exact C code for the traversing a linked list. In the fourth one, we have seen in detail line by line execution of a pseudo code and the C code for insertion of a node in the linked list at the beginning. So we'll continue this lecture where we'll see the insertion code of a new element at the last and at the intermediate positions. We'll also see the time complexity for both the method. We'll also see how to print the different linked list element. Okay, so we'll start. So in the last lecture, we have discussed the InsertAtBeg. So it has taken the list node star star head and int x. So we have discussed why it is taking the star star head, because in order to, we are changing the head every time. So in order to get reflected this change into the main function or the calling function or the globally, we have to we have to pass the address of the head. So head here, head value is 500, head is the name, the type is the list node star, and head address is 7839. The type of the 7839 is the list node star star. So that's why we are sending the address of head 7839, not the head value 500. We want this head to be modified inside the main function. So this was the code. So most crucial was the line number 4, where we are creating a new node by using the malloc function. So it takes the size of struct list node. So it is creating a new node and it is returning the address of the new node. So we are creating a new node and it is returning the address of new node, and that new node address will be assigned here. So you can see that we are creating a new node here. So this is the new node. This new node variable is here, but the creation of the new node is here. So you can see the creation of the new node is here with the content 550 and 500. So we, with the malloc line number 4, from the line number 4 we'll create this node 50 and 500, and then it will return the address of that node 400. We will assign that 400 to the new node, and then we'll just put the data. So this insertion time complexity, why? Because we don't have to traverse a loop. So insertion time complexity will be big O of 1, and the space we are not using any other space. So space we are using the constant time complexity. So it will be big O of 1. So in today's lecture we will discuss the printing linked list content and insertion logic at the last, how to insert an element at the last. We'll also discuss how to insert after kth position in a single linked list. So this is the outline of today's lecture. So we'll see one by one. So this was the yesterday content, InsertAtBeg. So the time complexity here will be the big O of 1, because we are just modifying the head pointer. We are not traversing the linked list, and the space complexity is 1. So we have already seen the code. So you can pause or you can go back to the previous lecture if you still have it out, and pin down your comment in the comment section. So we'll proceed. So this is the code to print the content of a linked list. So we'll go through the code. So we are passing a single head. So we are passing the single pointer to the head. We are not passing to the double pointer. Why we are passing the single pointer? Because we don't want to modify the head while printing the linked list. We have to just traverse the. So single head is sufficient. Single pointer is sufficient. Single pointer to head is sufficient. So we will first check the condition if head is null or not. If head is null, means the linked list is empty. It means the linked list is empty. So in that case we will just return. Otherwise we'll take a temporary variable list star temp. We will initialize temp to the head, and then here we are traversing the linked list. So traversal condition is traversing a linked list. So condition is till the temp is not null, we are going to traverse. Okay, so we have to suppose we have to take some example of the linked list. So we'll copy here. So suppose this is our linked list. Okay, so we have three node 1, 2 and 3. Head is containing the address of the first node. Okay, so first node address is 500, so head value is 500. So when we see the code, so if the head is not null, we will go to the while loop, while temp is not null. So temp will start with the head. So temp is a new variable. Okay, so temp is a new variable, and what we'll put here, so name is the temp. So temp initial value will be 500. So temp initial value will be 500. So and temp will point here. So since temp, what is the value of the temp now? Temp value is 500. Temp is not null, so entry condition of the while loop is satisfied. So it will enter into the while loop. So we'll see that temp next not equal to temp next is equal to null. It is false, so it will go to the else condition. It will print the temp data and a comma and the space. So basically the output side it is going to print what? 15 and then a comma, and then it will leave a space. Okay, then we are going to, for line number 95, we are doing temp equal to temp next. So currently temp is at 500, temp next will be 600. So we are going to update this value. So from 500 to 600 we are going to update this value, and so we'll update this. So we'll update the value of 500 and we'll put here 600. Okay, so let me delete this. So now temp contains 600. So temp is placed here instead of first node. Temp is now placed at the second node. Okay, so now we'll print, if we are inside the while loop, we'll check whether temp next equal to null or not. So temp next not equal to null, so we'll print %d temp data and we will print comma and a space. So what is the temp data now? Temp data is 7. So we'll print the 7 and we'll give a comma and the space. So then again we'll do the temp equal to temp next. So temp is value is 600 now, temp next contains 700. So we'll update 600 with 700. So we can, now temp is 700. So we can delete this 600 and we can put here the value that is 700. Okay, so after deletion temp will point where? Temp will go to this, temp will go to the last. Okay, so not also temp is not null. So what we are going to do, temp is not null, so we are going to print the temp data. Okay, temp next is null, temp is not null, but if condition, this condition is satisfied now. So this condition will be satisfied now. So what this if condition is going to be satisfied, so we have to just print %d, no comma, no extra space. This if and else is just for the formatting purpose. You can, instead of this two if and else, you can just have the printf single printf statement, printf %d comma and a space comma temp arrow data. So you can have just like this. You can, instead of both if else, you can remove both if else. You can have this printf %d and you can put a comma and the space. So like this. So you can put a comma and the space inside the double quote, and you can just put temp arrow data. Okay, so you can have just like this instead of this if else, but this is just a formatting so that there is no extra comma after the last element. So here we are at the last node, that's why the condition is temp next equal to null. So we'll just print 40, will not give any comma or any extra space. Now we are going to update the temp. So temp equal to temp next, the line number 95. So temp value will be modified as null because temp next is null. So we are going to modify temp to the null. Now when we check the entry criteria of the while loop, so temp not equal to null, so this criteria doesn't satisfy, so it will not enter to the loop. So after the previous update, temp has reached where? Temp has reached here, temp has reached to the null. So that's why we have traversed the complete linked list, we have printed all the content of a linked list, and the temp contains null now. So this we have exited the linked list. So this is the logic how to print the content of a linked list. So the main logic is first corner case to the check whether head is null or not. If head is null, we don't need to print anything. Otherwise, we need to take a temporary list node pointer which will start at head. We need to traverse till the temp not null. We need to print the temp data. So this is the logic to traverse all the nodes of a linked list. I hope this printing linked list content is clear to you. So then this time complexity for this. So because we are doing a traversal, so what would be the time complexity? So time complexity for this code would be big O of n. We are doing a traversal for linear time, so it will be proportional to the number of nodes in the linked list. Then what will be the space complexity? We are not using any extra spaces except the temp variable, so space complexity is big O of 1. So time complexity for this printing linked list is big O of n, space complexity is big O of 1. So we'll see the add last code. So in the add last code, we are passing similarly the head. Why we are passing the double pointer? Because in the add last also you might need to modify head. You might have the content or the linked list where you don't have any content. Okay, so let me let me copy this linked list to explain you the code. So this is the code, pseudo code to add at the last. Okay, so you can see the first line. We are initializing the two list node pointer. One is the new node, one other is the temp. So this line, similar to the add at beginning, we are creating we are creating a new node. Okay, so new node, we have to insert a new node, right? We have to insert a new node. To insert a new node, so we have assigned a new node temporary variable that will contain address of the newly node created. So suppose this is the newly node that we are going to create, and suppose x, the new data element that we are going to insert, is 50. So here data element will be 50, that will proceed later. And suppose this address, the address of this is 400. So we have one temporary variable named is name of this temporary variable. We have one temporary variable. So name of this temporary variable will be the new node. So let us create one new node. What does it contain? It can contain the address of any node. So now after the line 101, you can see we will have just a new node. We will not have anything else. We will have the new node, and its content will be some garbage value or empty value. Then in the line number 102, if we see the line number 102, here I will draw here. Let me. Okay, so here, so suppose we are a new node, we have a new node here. So we are creating a new node here. It has the two part. One part is the data part and other part, this part is the next part. First part is the data part, and this is a new node that we want to create, and there is one other pointer variable named as a new node that will contain the address of this new node. Okay, so what we are doing, we are using the malloc, we are creating this box. This is pretty important. This box, from the line number 102, we are creating this box. So that's why we are sending the size of list node. So size of list node means size of the data and the size of the next. So then of this size box it will create, and suppose if this address is 400, so it will return 400, and that 400 is going to be assigned into the new node. So new node equal to the malloc size of list node. So after this node is going to be created, and this malloc is going to return 400. That 400 is going to be assigned into the new node variable. So after assigning the 400 variable here, we are going to put the data. So data is now 50, so we are going to put 50 here, and this is the first node, right? So this is the last node. We are going to add the new node at the last. So this would point to the null. This would point to the null. So we are going to put the new node next to null. So what we are going to put here, null. So these three processing we are done. New node data x, new node next equal to null. Now we'll check what is the value of head. So one corner case, that head is empty, means there are no elements in the linked list. In that case, we need to update the head. So why we are again is using the star head concept, we have already discussed at the beginning of this lecture. So head is a name. What is head? Head is a name of the variable. What is 500? 500 is the content or the value. 500 is the content or the value. And head would also have an address, right? Suppose head address is 7839. So this becomes the address of the head. Okay, so address of the head. So we are checking star head. Star head means value at 7832. So it means the value at head will contain 78. We are passed the address of head. So value at 7839. So this value will contain the 500. Now if it is null, we have to modify star head to the new node. So we have to modify star head to 400. Otherwise, what we need to do, we need to take a temporary variable like we have seen while the traversing code, and we have to traverse till the last node, not to the null. We have traversed to last node. So to traverse last node, we have to tell temp next not equal to null. So this condition is also important. Why we have used temp not equal to null in the previous case while the traversing of the linked list, while printing of the linked list, but in this case we are using temp next not equal to null. So what is the difference between the condition temp not equal to null first and this second temp next not equal to null? So please think, I am giving you few seconds to think the difference between these two conditions, temp not equal to null and temp next not equal to null. So try to iterate through this. If while condition is temp not equal to null and while condition temp next not equal to null, so what will be the difference? So when temp not equal to null, temp will keep on iterating each node and it will stop. The temp value will terminate at the null. So it will not stop at the last node, rather it will stop at the null. While in the second case, temp will keep on iterating and it will stop at the last node. Why? Because the last node next will be null and we need the address of the last node. We want to add the new node here. So we have to give this condition. Okay. So after this, we have to use this temp next equal to new node. So instead of head, we have to update this null and we have to update to the new node. So what is the new node value now? New node value is 400. So we have to update, instead of null, we have to update here 400. So by updating this, a link will be established from this to the last node, and a new node is inserted at the last node with value 50. I hope this is clear to you all. So for any doubt, you can write your doubts in the comment section. So time complexity for this algorithm is big O of n, and space complexity is big O of 1. So in the coming lecture, we are going to discuss how to add a new node at the after the kth position. So we have discussed in this lecture what we have discussed. We have briefly revised how to add a new node at the beginning. We have discussed how to print all the element of the linked list. We have discussed how to add a new element at the last. Thank you everyone. So see you in the next video.